I was sitting in my car the other day, dead stop in traffic.
Oh, the best place to be.
Right. Just trying to load a map on my phone. And I look at the screen and I've got full bars. I mean,
Yeah.
5G, the works, and yet nothing. Just the spinning wheel of death.
Yeah, it's incredibly
It
frustrating.
really makes you wonder, we have these incredibly advanced chips, fiber optics everywhere, satellites in orbit. Why is it still so glitchy? Why does it feel like our tech is constantly, I don't know, fighting against the world it lives in?
That is the eternal frustration, isn't it? I mean, we build these very rigid engineered systems, and then we're surprised when the real world, which is, messy and chaotic, doesn't play nice with them.
Exactly. And usually the answer you hear is just add more power or build more towers.
Right. Brute force.
Yeah, brute force.
Okay.
But today, for this deep dive, we're looking at a source that suggests the problem isn't the hardware at all. The problem is the math.
And it's a bold claim. We are looking at a document titled Transformation from Multicode 4.0 to 6.0. And I gotta say, when I first started reading this, I genuinely thought I'd picked up a sci-fi novel by mistake.
I had the exact same reaction.
It's proposing that we redesign our entire digital communication architecture, not based on binary logic, but on the resonance patterns of the universe.
Yeah, resonance patterns, which sounds lovely, but I admit my skepticism radar went off immediately. I'm used to engineering papers talking about voltage and silicon, not the heartbeat of the cosmos.
Sure.
But the more I read, the more I realize they aren't talking about magic here. They're talking about efficiency. So let's unpack this. The text frames this whole thing as a battle between two systems, Multicode 4.0 and Multicode 6.0. What exactly is the war being fought here?
The war is essentially against friction. The source argues that our current standard, Multicode 4.0, is a linear bit-oriented system.
Okay.
It was built on a logic that works great on a whiteboard,
Yeah.
straight lines, rigid grids, but, well, nature hates straight lines.
Right. Nature likes curves, spirals, waves.
Exactly. So when you force high-density data through a linear system, you create drag, you create heat. You eventually hit a wall where the signal degrades just because it's fighting the medium it's traveling through. Multicode 6.0 is the proposed solution to that.
The resonance-based architecture.
Yes. The goal is to align the signal with the fundamental mathematical constants of nature so that the friction just disappears.
So instead of a boat smashing through the waves, it's a surfer riding them.
That is the perfect analogy. And the claim here is massive. The authors argue that specific numbers aren't just tools we use to count inventory or whatever. They say numbers actually structure physical reality.
Which is a huge paradigm shift.
It is, and if your tech doesn't mimic that mathematical structure, it will always be inefficient.
Okay, so let's get into the weeds, or I guess the honeycomb, based on what we're about to talk about.
Uh-huh.
Because the text spends a lot of time just trashing the number 5. Poor number 5.
It really does.
Apparently, Multicode 4.0 is based on the prime number 5. Why is that such a problem?
It comes down to geometry. Multicode 4.0 used a pentagonal symmetry and this linear 8-core 0 logic. Now imagine you have a bunch of pentagons, 5-sided shapes. Try to tile a floor with them.
You can't. You'll have gaps everywhere.
Exactly. Pentagons don't fit together perfectly. They leave empty space. In a digital system, those gaps represent inefficiency. As data rates get higher and higher, that pentagonal structure becomes unstable. It literally can't handle the density.
So the fix is to swap out the number 5 for the number 11.
Ideally, yes. The new architecture, Multicode 6.0, is built around the prime number 11 and the semi-prime 77.
Which is just 7 times 11.
Correct. But the reason 11 is the hero here relates to the work of a researcher named Peter Plichta. He's a chemist and mathematician who proposed the prime number cross theory, or PZK.
Yeah, I fell down a bit of a rabbit hole with Plichta. It's pretty dense stuff. Can you give us this sort of explain like I'm 5 version of that?
Sure. So we usually think of prime numbers as random, right? They just pop up wherever they want on the number line. Plichta says, no, look closer. He argues they follow a strict mathematical law based on the number 6. The formula he uses is 6n plus or minus 1.
Meaning every prime number is sitting right next to a multiple of 6.
Exactly. Take 11, it's 12 minus 1. Take 13, it's 12 plus 1. 17 is 18 minus 1. And if you map this out visually, it creates a hexagonal structure, a honeycomb.
And unlike pentagons, hexagons tile perfectly.
Bingo! No gaps. So by moving to an architecture based on 11 and 77, the document claims you're essentially building a honeycomb for your data. You can pack information much tighter, giving you a higher state density, without the system becoming unstable.
So we're creating this clunky grid for a hyper-efficient hive. That makes sense on a structural level. But then the text introduces another number, and this one acts as a sort of mechanic for the system, the tool of 36.
Right, the number 36. In this theory, this is the central ordering element. It's the stabilizer.
But how does a number stabilize a microchip?
Think about chemistry again. The text uses an isotope analogy. An atom needs a specific balance of neutrons to stay stable. If that balance is off, the nucleus falls apart. It decays.
Like radioactive decay.
Right. In this digital system, the tool of 36 is used to calibrate those 8 core 0 processing units we mentioned earlier. It synchronizes them with the transmission medium.
Like a tuning fork.
Yes, exactly like a tuning fork. It ensures that the processor and the signal are singing the exact same note, preventing the data from decaying into noise.
Okay, I'm with you so far. We've got a hexagonal foundation, a tuning fork to keep it stable. But this is where the document takes a hard left turn to what honestly feels like mysticism. We stop looking at the calculator and start looking at the sky.
Ah, the resonance part of the title.
Yeah, they start talking about the rings of Saturn. And I have to ask, is this serious? Are we really saying that our Wi-Fi needs to care about what a gas giant is doing a billion miles away?
I know, it sounds completely absurd at first glance, but follow the logic. The argument is basically, why invent a new frequency when the universe has been beta testing frequencies for billions of years?
Right, nature's R&D department.
Exactly. The universe has already settled into stable rhythms. If you want your computer chip to be stable under massive loads, don't just pick a random clock speed. Pick a speed the universe already uses to stay stable. And that leads us straight to the Fibonacci numbers.
The classic sequence, 1, 1, 2, 3, 5, 8.
And it keeps going. The source highlights 2 very specific Fibonacci numbers that act as resonance keys for multicode 6.0, F19, which is 4181, and F23, which is 28657.
Again, why those two? Why not F10 or F50? It feels like they just threw darts at a chart.
But the source claims they didn't pick them, they found them. These numbers correspond to actual stable vibration modes in our solar system. The text explicitly mentions the resonance patterns in the rings of Saturn, the orbit of Jupiter, and even in protoplanetary disks, you know, the dust clouds that eventually form solar systems.
So the rings of Saturn are essentially humming at the number 4181.
In terms of mathematical ratio and frequency, yes. These large cosmic structures have survived for eons because they locked into these specific mathematical grooves. They are stable. If they weren't, they would have flown apart millions of years ago.
So the idea is if our data signals draft behind that cosmic stability, they won't fly apart either.
Precisely. It's like swimming downstream. If your system timing mimics these cosmic vibrations, the signal naturally resists interference. It's harmonizing with the background noise of the universe rather than trying to shout over it.
They even mention a specific star. They call it star music.
Yes, they pull data from the Kepler Space Telescope regarding a star named EPIC 215776487.
Not exactly a catchy name for a top 40 hit.
No, but it's a rock star in this context. This star oscillates at frequencies that exactly match these Fibonacci resonance keys. The authors are using this as a proof of concept. They're saying, look, this resonance works in the blazing, chaotic heat of a star. It will certainly work in your smartphone.
It's wild. But just when I wrap my head around the astronomy stuff, the text drags us all the way down to the microscopic level, the DNA connection. This is the part that made me stop and reread a few times.
The biological resonance aspect.
Yeah. They claim that human mitochondrial DNA contains numerical metastructures that match these exact same numbers, 4181, 6765, 18946.
It's a fascinating triangulation. You have the macro, the stars, and the micro, the DNA, both converging on the exact same map.
Wait, so are they saying the code that runs my cells matches the code that runs the rings of Saturn?
That is the implication. And for the engineers designing Multicode 6.0, this is the holy grail. Because DNA is the ultimate storage device. Think about it. It is incredibly robust. It error checks itself. It survives mutations and radiation and lasts for thousands of years.
So how does a digital network actually use that? Are we putting biological DNA in the silicon chips?
No. We mimic the logic. The text mentions the base pair ratios in DNA, cytosine plus adenine versus thymine plus guanine. The digital architecture uses these exact biological ratios to check for data corruption.
Okay. Because normally a computer checks for errors by doing a checksum, right? Basically adding up the ones and zeros to see if they match what was sent.
Right. But here, instead of asking, is the sum correct? The system is essentially asking, does this data look like DNA? Does it adhere to the golden ratio?
And if it doesn't,
then the system knows instantly it's an error and corrects it. It brings a level of integrity to the data that standard binary checks just can't touch. We're essentially outsourcing our quality control to millions of years of evolution.
It's a wild synthesis. We are building a digital network that vibrates like a star and error checks like a human cell.
It suggests that the best engineering isn't invention, it's biomimicry.
But let's ground this a bit for a second.
Yeah.
Because all this grand theory still needs to run on actual chips, actual hardware.
Yeah.
We can't just, vibe our way to a better internet. The text talks about high-state systems and the 8-core Zero processor. And there's some very specific, what they call magic numbers, mentioned for the implementation.
Right. You need to translate the philosophy into physics. One of the critical numbers mentioned for the hardware calibration is 24257.
24257. Now, I saw a note that this came from the medical field.
It did. The source notes that this value is highly significant in medical imaging, specifically echo-vulnar imaging and MRG, which are advanced brain scanning techniques.
Why does a cell tower care about brain scanning?
Because of absorption. One of the biggest problems with wireless signals is that the physical world soaks them up. Water, trees, people, we literally absorb radio waves. They found that the value 24257 relates to how signals are absorbed in biological media and fluids.
Okay, I follow.
In Multicode 6.0, they use this specific number as a calibration point for adaptive power control.
Which means what, practically speaking?
It means the system knows exactly how much power to use to punch a signal through the air without wasting energy. It's like knowing exactly how hard to throw a baseball so it lands perfectly in the glove without stinging the catcher's hand. It's optimized for the physical world.
That's actually really smart. But there was another number that sounded a bit more like traditional computer math. 6537.
Ah, the Fermat prime.
Yeah.
2 to the power of 2 to the power of 4 plus 1.
You've been waiting to say that equation.
It's a beautiful number. It's an absolute celebrity in the world of mathematics. It's used in RSA cryptography, which protects basically everything we do on the internet. But in this multi-code 6.0 context, it's used for WCDMA systems, wideband code division multiple access.
That's the tech behind 3G and 4G networks.
Correct. And by using the Fermat prime 65537, the source claims the system can generate infinite orthogonal channels.
Okay, orthogonal channels. That's a $10 phrase right there. Break that down for us. What does it actually mean for you, the person trying to watch a video on the bus?
Imagine you're at a really crowded cocktail party. Everyone is shouting, it's loud, it's chaotic, and you can't hear the person standing right next to you because all the sound waves in the room are crashing into each other. That's a normal network dealing with interference.
Okay, I've been to that party.
Now, imagine that everyone in that room is speaking on a mathematically orthogonal channel. In physics terms, it means their sound waves are perfectly perpendicular to yours. They literally cannot interact with your conversation.
So even if 1 million people are shouting in the same room, my conversation is crystal clear.
Exactly. The waves pass right through each other without mixing. So for the end user, it means the network doesn't slow down just because a lot of people are using it at the same time. It essentially creates infinite lanes on the highway.
That would be a massive game changer. But there was also a section on thermodynamics that I found pretty intense. They started talking about the Curie temperature of a signal. Now, I remember high school physics, Curie temperature is about magnets, right? It's a temperature where a magnet stops sticking to the fridge.
That's exactly right. The Curie temperature is the tipping point, where heat makes the atoms in a magnetic material too chaotic to stay aligned. The magnetism just vanishes.
And they're applying this concept to data.
Yes, and this is a key shift in their thinking. They are treating information as a physical substance. They use Monte Carlo simulations to find the Curie temperature of the data stream itself.
Wait, so a digital signal can literally melt?
Metaphorically, yes. If the system is under too much stress, say too much data, too much interference, the ordered resonance of the signal can get too hot and it turns into chaotic noise.
So they model the data like it's a piece of iron in a furnace?
Exactly. By using the Heisenberg model of magnetism, they can predict exactly when a signal is about to demagnetize into noise, and because they can predict it, they can cool it down or stabilize it before your call drops.
It's amazing how they treat data not just as abstract code, but as a material. Something that has temperature and magnetic spin. It feels much more tangible.
That's the recurring theme here. Data is physical. It obeys the laws of physics, so we should engineer it using physics.
But this brings up the question of control. If we have this incredibly complex, resonating, star-mimicking, magnetically modeled system, how do you drive it? If it's vibrating with the universe, how do you stop it from just flying off the rails? The text mentions sliding mode control.
SMC. This is a very robust control strategy used in engineering to handle chaos. Think about driving a car on an icy road.
Okay.
You hit a patch of ice and start to slide. To keep the car on the road, you can't just hold the steering wheel straight. You have to make rapid micro adjustments left, right, fighting the slide to catch the traction.
Correcting the drift.
That is sliding mode control. It switches states rapidly to force the system to stay on what they call the sliding surface, which is the safe path.
And there were these specific sequences mentioned. 1-2-2-2-2-2 and 2-1-1-11. When I first read them, they looked like typos or glitches in the text.
Far from glitches. Those are the steering instructions. The sequence 1-2-2-2-2-2 corresponds to the value 6. That is the acquisition phase. That's the system grabbing the wheel the second the slide starts.
And the other one.
2-1-11, value 34, that's the correction phase. It's the rapid-fire adjustment that pulls you back into the correct lane.
The text used a really interesting analogy for this, too. It compared it to radioactive decay again.
Yes, alpha decay chains. In nature, a radioactive element is unstable. It spits out energy rapidly until it turns into something stable, like lead. This sliding mode control mimics that exact physics. It rapidly switches states to force the instability to decay into a stable signal. It's forcing order out of chaos by literally copying nuclear physics.
And does this affect the hardware itself? I remember seeing a mention of membranes.
Nafion membranes. You usually see these in fuel cells. The source points out that hardware generally degrades. It wears out because of chemical stress.
Normal wear and tear.
Right, but often that wear and tear is caused by internal vibrations that fight against the material's natural structure. The document claims that if you match the hardware's eigenfrequencies, its natural self-vibration, with these system frequencies of 11 and 77, you drastically reduce that chemical degradation.
So the tech literally lasts longer because it isn't fighting itself. It's harmonized.
Exactly. It's like pushing someone on a swing. If you push at the right moment, it's effortless. If you push at the wrong moment, you jolt the whole frame. Multicode 6.0 is about always pushing at the right moment.
Which brings us to the end of the document and really the philosophical implications of all this. We're talking about mirror images and chirality.
This loops all the way back to Peter Plichta and stereochemistry. In nature, molecules have a handedness. You have left-handed molecules and right-handed molecules. They are mirror images, but you can't superimpose them. Just like your hands, they look the same, but a left glove doesn't fit on a right hand.
Right, I'm with you.
In Multicode 6.0, they treat signals as mirror images using orthogonal polarizations.
But what is the actual benefit of that? Just to be symmetrical with nature.
No, it's about capacity. If you can send one signal left-handed and another right-handed through the exact same space at the exact same time and they don't touch, you've just doubled your bandwidth.
Without laying a single extra cable.
Exactly. It's a trick learned entirely from the geometry of space itself.
It really feels like the grand vision here is dissolving the line between the machine and the natural world.
That is the explicit goal. The text references Jan Grzelski and his vision of an energy geometric code of nature. The shift from Multicode 4.0 to 6.0 isn't just a software upgrade, it's a philosophical shift. We aren't just building faster processors, we are building processors that understand the code of nature.
Moving from a 5-based logic that was just, good enough, to an 11 and 77 resonance that vibrates with the universe.
It suggests that future technology won't just process information. It will vibrate in perfect harmony with everything from DNA strands to planetary orbits. It's a beautiful, if highly theoretical, concept.
It really makes you look at your phone differently. You wonder if one day the signal connecting your call will be humming the exact same tune as the rings of Saturn.
And if this source is to be believed, that day might be a lot closer than we think.
So here is where we leave you to think. We always view technology as something artificial, something we build to conquer nature or tame it. But this entire deep dive suggests the complete opposite, that the ultimate technology is one that actually surrenders to nature's math.
It definitely raises the question, if our digital codes start mimicking the music of the stars and the structure of our own DNA, at what point does the line between technology and nature disappear entirely? Are we building computers or are we just creating synthetic life?
Something to chew on the next time you're waiting for a web page to load. Thanks for joining us on this deep dive into the architecture of resonance.
A pleasure as always.
See you next time.